Hi everyone. For part 2 of 5.2, what we want to do is focus on parallel and perpendicular lines. And the first thing I want to do is talk about what each of those words means, and more importantly, what it means about an equation of a line. So let's start with parallel lines. We say that two lines are parallel if they point in the exact same direction. Meaning if you extended them forever and ever and ever, no matter how far you extend them, they'll never intersect. They'll never cross each other because they're both going the exact same direction. So here's an example of two sets of parallel lines. And here's the important part for equations. The way you know that lines are parallel is they have the same slope. So if I take a look at these two lines right here, let's say I took the dark blue line and I wanted to do rise over run. I need 2 points. I might pick this point right here and maybe this point right here. Those are two good points that are definitely on the line. If I do rise over run, it's going up 3 and then left 2. So the rise over run would give me -3 over +2. That would be my slope. Actually, you know what? I got the signs backwards. It would be +3 over -2. That's better. Up 3, +3, left 2, -2. Now if I do the same thing with the light blue line, maybe I'll pick this point right here, that would be a good one, and this point right here. See, it's the exact same rise over run. It's up 3 and left 2. So you get the same slope for both of them, the same rise over run. Now because you have the exact same slope, that's how you know they're parallel lines. Now the second word from the title, perpendicular. Perpendicular means right angle. It means two lines that make a perfect right angle or a perfect 90-degree angle. Now here's an example of two perpendicular lines. We have the red line and the blue line. And if you notice right where they meet, there's that little square symbol. The square symbol is a way of showing a right angle, showing that it's a 90-degree angle, or basically saying that those lines are perpendicular. Now these two do not have the same slope. The trick for perpendicular lines is that the slopes are what we call opposite reciprocals. Now, each word means something different. Opposite means one thing, reciprocal means another. So let's go one at a time. The word opposite is talking about the positive-negative sign. So in order to have perpendicular lines, you have to have one with positive slope and one with negative. If they're both positive numbers, they're definitely not perpendicular. If they're both negatives, they're definitely not perpendicular. So number one, you have to have one positive and one negative, but they also have to be reciprocals. And the word reciprocal is when you flip a fraction. So one example of a reciprocal would be the fraction 2/7, or 2 over 7, and 7 over 2. It's a fraction where you have the same numbers, but you flip it. You flip the top and the bottom. So the first one was 2 over 7. The second one was 7 over 2. Those are reciprocals. Or, like the example I just showed you, what you notice here, the slope of one of them is +3. Because remember, I gave you the equation in this picture for both of them in slope-intercept form, y equals mx plus b. So the number in front of x is the slope. So the slope here was +3, and the slope here is -1 over 3. One of them is positive and one of them is negative, and they're reciprocals. So I said the number 3 and 1/3 are reciprocals, because remember, like when you're doing rise over run for slope, the number 3 as a fraction is 3 over 1. So 3 over 1 and 1 over 3 are reciprocals. So if you have a whole number like 3, and then 1 over that same number, like 1/3, one of them positive, one of them negative, they're definitely perpendicular. And that's going to lead to our first example for today. So I'm going to give you guys two equations, y equals 2x plus 5 and 2x plus 4y equals 10. And I'm going to ask you guys, are these two lines parallel, perpendicular, or neither? So what we want to do is figure out the slope of both lines. If we get the same slope for both of them, the exact same thing, we say they're parallel. If the numbers we get are opposite reciprocals, we say perpendicular. And if it's anything other than those two very specific things, then we say the lines are neither parallel nor perpendicular. So let's find the slope. And actually for the first one, just like the pictures from before, it's right there for you. For the first line, the slope is 2. But the second one is, and I knew that because it's slope-intercept form, but the second one is what we called standard form, and you can't tell the slope just by looking at it. You got to do a little bit of work. Now what I'm checking here, I want to find the slope of the second line. If the slope of the second line is also 2, then they're parallel. If the slope of the line is -1/2, they're perpendicular. And if I get any other answer, if I get 0, 1, 10, a million, like anything else, then they're neither parallel nor perpendicular. But we got to find the slope of this one. And I think the best way to do it is like we did in part 1 of this section, where we take standard form and we rewrite it in slope-intercept form. So let's basically solve this equation for y. If I want to solve for y, I want to move the 2x to the other side, and I do that by subtracting 2x from each side. To cancel it out, the 4y stays. Now, notice I didn't put the 2x right under the 10 because I'm not going to subtract it. Those aren't like terms. You can't combine them. I have two separate pieces. I have a 10 and I have a -2x. I could say 10 minus 2x, but I'm going to flip them because remember, we want it in slope-intercept form. I want the x part first, so I'm going to put the -2x first. And then that positive 10, since it was positive, I'm going to end with a plus 10. Now, to finish putting into slope-intercept form, we just need it in y form. We need to cancel out that 4 instead of in front of y. So I'm going to divide everything by 4. And we end up with y equals, now remember, I'm looking at this right here to reduce. I'm going to leave the x, and I'm looking at that right there. -2 divided by +4, it's definitely negative. 2/4 is a fraction. It reduces to 1/2. And actually, I can answer the question right now. I don't even really care what the plus 10/4 reduces to, because that number right there is the slope. Now that I know that, remember, I was trying to figure out if they're parallel, perpendicular, or neither. These lines are perpendicular, because those two numbers are opposite reciprocals. One of them was positive, one of them is negative. One of them is 2, one of them is 1/2. They are opposite reciprocals, so the answer to the question is perpendicular. Now, if I did need to know the rest of the equation here, remember I had this plus 10/4, this number here. I could say 10/4 reduces by 2 and call it plus 5/2. But like I said, I didn't even need that. Once I saw this number right here, compare it to this number right here, you're asking yourself, are they exactly the same? If so, parallel. Are they opposite reciprocals? If so, perpendicular. If it's any other relationship, you say neither. Okay, for our last example today, I'm going to do a two-parter, part A and part B. I'm going to say I want us to write an equation of a line that goes to the point 4, 1 and is parallel to y equals 2x minus 3. So remember, when I give you a point in a question, what I'm giving you is an x and a y. We're going to go back for this one. There's actually two ways to do it. You can use slope-intercept form, or since we just learned it for this section in part 1, let's use point-slope form. Let's use y minus y1 equals m times x minus x1. And if I'm going to do that, then go back to this point 4, 1. I'm now going to use it as my x1, y1. Because remember, that's how we use point-slope form. We plug in the number, we leave the regular x and the regular y, and we plug in numbers for x1 and y1. So the only thing I really need to finish this question is the slope. Now, if I want this line to be parallel to y equals 2x minus 3, then I want it to have the same slope, which is 2. So for this question, I'm going to use m equals 2. Now let's go ahead and put all of our numbers in. I have y minus, now y1, if you look above, that's a 1 in this question, equals m, we just decided we're going to use 2 for m, times, and then you leave the x, and we're going to subtract x1, which comes from the point, and that's 4. Now, that's fine. You can just leave your answer like this. If you want your answer in slope-intercept form, you can distribute the 2 and add 1 to both sides. But you don't need to. We can stop right there. Okay, for part B, let's do the exact same question. So the point 4, 1 again. This time, instead of parallel, we want it to be perpendicular to y equals 2x minus 3. I'm going to answer the question the same way. I'm going to start with point slope form. Y minus y1 equals m times x minus x1. I'm going to go to my point. I'm going to use the 4 and the 1 as the x1 and the y1. The only thing that's going to be different about this one is I'm going to use a different slope, because I want it to be perpendicular to this line right here. The slope of this line is 2. If I want my line to be perpendicular, then its slope needs to be opposite reciprocal. So instead of positive 2, I'm going to use negative 1 over 2, or 1/2. Now let's go back and put the numbers in again. So leave the y. Y1 from the point is 1. That part is the same. M, this time instead of 2, is negative 1/2. Leave the x, and then minus x1, which is 4. And I think what I want to do, let's actually finish this question out. Let's say, even though I didn't ask you to, we could stop here, and it would be good for an answer. Let's show you one more time how to turn point slope form into slope-intercept form. Because if I wanted to do that, I could do it in 2 steps. Step 1, leave the y minus 1 part, but do a distributive property with the negative 1/2. You go negative 1/2 times x, just put them together, negative 1/2 x. And then when you do negative 1/2 times negative 4, negative times negative is positive, and 1/2 times 4, or 1/2 of 4, is 2. So I did the distributive property. Now see, the last step to finish solving for y is to get rid of the minus 1 in front of y. And I could do that by adding 1 to both sides. And for my final answer here, I get y equals negative 1/2 x, and then 2 plus 1 would be plus 3. So remember, you didn't have to go that far. If you stopped here, that's fine. You did it. That was the answer in point slope form. But I just wanted to remind you of how to turn point slope form into slope-intercept form in case you need to do that. You can always do it with 2 extra steps. Distribute the slope, and then either add or subtract to cancel out the number that comes after the y.